Okay, so next I want to quickly mention the connection between dynamic programming and DAGs, something that I already earlier mentioned, but let me try to make it explicit. We will revisit it later in the course when we speak about DAGs. So DAG, to remind, is a directed acyclic graph. It's a directed graph that doesn't have cycles. Such graphs are really nice. They have some nice properties, which, as I said, we will see later on. And the connection is essentially that we have this, when you have a dynamic program, we have a table that we want to fill. We have values we want to compute. If you want to think about it, recursive function, we have distinct calls to the recursive function. And we can build a dependency graph where we say that a value depends on another value, a distinct call depends on some other distinct call, if we need to compute this other value before we can compute this value, right? If we do the table way of things, then every entry in the table depends on some other entries in the table, right? So we can build this dependency graph when entries points to what it depends on, similar in some sense to how makefiles work, if you know makefiles. So we create this dependency graph. This dependency graph better would not have cycles, because if we have circular dependencies, then we are not going to be able to compute the values, at least not by this approach. And now, computing this, the optimal solution, turned out into a problem of finding the shortest path in a DAG. Or if we are speaking about the longest common subsequence, in fact, it boiled down to computing the longest path in this DAG. And as such, there would be a lot of problems where you would like to think about it as recursive functions, then you would like to think about this as dependency graph, and then you would like to solve the graph problem dependency on defined over the dependency graph. And there would be cases where you benefit quite a bit by thinking about this as dependency graph. And of course, the important thing about this dependency graph is that it's implicitly defined. So you don't really need to build it explicitly and run the algorithm. It's kind of an implicit structure. You kind of figure out what the graph problem is that you're trying to solve by the dynamic problem, and you solve it on the DAG. So this is really turned out to be very neat, and we will go back to it later on. Okay, so just remember that dynamic programming has a deep connection to DAGs, and problems on dynamic programs are also related to problems on DAGs. And this is it for now.